so another similar-ish kind of example. This time we're told the acceleration is minus 1.53, so write that in. The initial velocity 2, 3. Find the time when the particle is at the point position vector of 1, 4. So you've got to be very careful when you use position vectors. This one tells us originally it was at the origin and now it's at the point 1, 4. So as well as being its current position, that's also the displacement over the time it's talking about 1, 4. Sometimes the positions are red herrings, if you will. So you have to be a little bit careful, but I've read that through carefully. I'm happy with that. So that gives us 3. We want the time where that occurs. So the equation without v, which is s equals ut plus a half at squared. If you've not already got a formula sheet from Moodle, it's probably a good time to have one, maybe bookmarked on your phone, open as a tab on your phone, bookmarked on your computer, whatever you're using. Print it off if you can. So it's on Moodle, but it's useful for knowing what things you do and don't get it in particular. Okay. So similar kind of process to the last question. Vector there, 1, 4. 2, 3 vector times by t that we don't know yet, and then half minus 1.53 and then t squared. And then again, I think I did this in an earlier example. I'm going to write these out, basically 2 separate lines, one for the horizontal, the I/x direction if you will, one for the j/y direction. So the first one is going to be 1, and that's for this top line here, equals 2t, and then minus, so half times that, so that's minus 0.75 t squared. And then the second line, so 4 equals 3t, half of 3, so positive 1.5 t squared. Now there's 2 slightly different ways of going about this. I'm just going to rearrange them both into a nicer form now. And again, top one's going to go on top, bottom one's going to go second. So it's going to be positive 0.75 t squared. I'm taking that to that side. Take away 2t plus 1 equals 0. And then the next one, positive 1.5 t squared. Take away 3t plus 4 equals 0. So depending in particular on what technology you've got available to you, there are 2 ways of going about and solving this. One is that you could solve one of the equations, okay, it should have 2 answers hopefully, and then sub both of those answers into the second equation and see which one works, hopefully one will work. Secondly, if you've got the graphical calculator, I'm just going to solve both of them quickly in my calculator and then look for a consistent answer. So I'm going into the polynomial mode, degree 2. So our top equation here, so 0.75 minus 2 positive 1 is going to give me answers for time of 2 and 2/3. You can hover over that if you're not sure about the 2/3 one. And then I'm just going to type the 1.5 minus 3 and plus 4 in. So 1.5 minus 3, 4. And I've done something wrong there. Oh, I've rearranged it slightly wrong, haven't I? So it's positive 3 there it should be. Didn't, and minus 4. Okay, so change those, I got wrong. And I've now got 2 answers, which are not giving me the right numbers. Let me have a look what I've done wrong. So, oh. I remember at this point, in fact, I think I've changed it in my PowerPoint, but not in the notes. So this 3 is the wrong number. Now I remember. So that 3 should actually be a 5. I need to change that in the gap notes properly. In fact, by the time you watch this, I might have already done that. So it should be 1.5, then 5, then take away 4. And there we go, that's the right answer now. Okay, so that gives me for this equation solutions of t equals to 2/3 and t equals to -4. So our answer overall is time is 2/3. Okay, so by the time you've done this, you might not even notice I might have changed that vector to 2, 5. Okay.